Hello again everyone, this is question number 1 from textbook chapter 8.2. So the question is asking us, from a random sample of weights of dollar coins, we constructed this 95% confidence interval estimate of the mean. So they're saying the population true mean is somewhere between 8.0518 gram through 8.0920 grams. Interpret this confidence interval. So we know that confidence interval is basically a single sample's x bar plus minus margin of error. So plus margin of error and minus margin of error. And these two margins of errors keep this x bar right in the middle. And this confidence interval is telling us that the lower bound of this margin of error is 8.0518, and this upper bound is 8.0902 grams. So to find each of these margin of errors, we can just take this whole distance and divide the distance by 2. So if I use my calculator, I can just deduct this lower bound from the upper bound to get the whole length of this confidence interval. Let's do that. So upper bound is 8.09020902. I'll deduct the lower bound from it, which is 8.0518. 8.0518. And that gives me the total length of the confidence interval to be 0.0384. 0.0384. That is the total length of the confidence interval, and each of this margin of error must be half of this distance, this whole distance, which is my confidence interval. I'm just denoting confidence interval by CI. So I can divide this 0.384 to get my margin of error. So going back to calculator, I'll divide this 0.0384 by 2, and that would give me 0.0192, my bad. 92. So this is positive 0.0192, and this is my negative 0.0192, and those are my margins of errors. And if somebody asks us to interpret the confidence interval, we can just say that the true population parameter lies somewhere between this value and this upper value. Now, on a related note, if somebody asked us, well, what do you mean and by this confidence interval, what is this 95% confidence interval? Then we could explain that by using our concept of the sampling distribution of sample means. Let me just take you to that discussion for just 1 or 2 minutes. In that way, you'll really understand what's happening, what's the logic behind this 95% confidence interval. So we know from our sampling distribution of sample means that from a population of large number of observations of x's, if I took thousands of samples and calculated the thousands of respective x bars and plot those thousands of x bars in a histogram, the histogram would show a normal distribution where the mean of all those x bars would be exactly equal to the population mu mean mean mu, and by the rule of 68, 95, 99.7, we know that under any normal distribution, 95% of the observations lie within plus minus 2 standard deviation of mean, minus 2 standard deviation of the distribution of X bars. So that means that out of all these possible thousands of X bars, suppose these dots are different X bars that I can possibly estimate from different samples. Out of all these thousands of X bars, 95% would be found within this plus minus 2 sigma from the true population means. That is the same thing as saying that 95% of all these X bars would contain the true population mean within plus minus 2 sigma of these X bars. It is just like saying that if this X bar is within plus minus 2 sigma of mu, then mu is also within plus minus 2 sigma of this X bar. And therefore, as 95% of these X bars with its interval would contain the truth, we are 95% sure that if we randomly pick any of these thousands of X bars, 95% chance it contains the true population mean within its plus minus margin of error, i.e. within its confidence interval. So that's how we got this idea that within plus minus 2 standard deviation away around the mean of my single sample, there's a 95% chance that the population parameter is existing. So I hope that reviews some of the ideas that we learned before, and I'll come back with more answers for you later. For now, bye bye.